Class, so here is Unit 8. We're going to start talking about quadratics, okay? What is a quadratic? Well, it is an equation that has an x squared like that, okay? Before I keep going, I do want to talk about, well, what is not a quadratic? What is not a quadratic would be maybe things like if you had something like y equals, I don't know, 3x cubed plus, let's say 2x squared, something like that. Even though this has an x squared, you see that this has a cube, which makes it like 3 is higher than 2, so that makes it a cubic function, not a quadratic. Okay? Yeah, I think I'll probably just leave it there, and I'm going to go ahead and erase this. All right, now let's get into quadratics. The first thing I want to talk about is this word parabola. Okay, what is a parabola? Parabola is the graph of a quadratic function, and it's a U-shape. So let me give you an example here. Let me go ahead and type this parabola in here, the little equation that I have here. Okay, x plus 5. Whoops, 5. All right. Well, here you go. You see the shape right here? It's not exactly a V, it's not exactly a U, it's just kind of mixed together. But anyway, that is a quadratic. Another word that we have for the word parabola is the word, like sometimes we say curve. Where should I write it? I'll say curve as opposed to a line, okay? Let me show you what, the graph, when you see certain graphs and you know it's a quadratic versus not a quadratic. For example, like let's say if you have linear, let's say 2x. The graph right there in the green, that's a line. That's not a quadratic, it's a linear. Let's do cube. Let's see what happens when I throw in a cube. See, it has a curve, but it doesn't have that parabola shape. Okay? One more I'll go over is a 4. Like if I put in a 4, notice that it's kind of flattens out at the bottom. That's a quartic, it's x to the 4, so that's also not a quadratic. Okay? Anyway, hopefully you can see what parabolas look like. They generally have that shape. All right, so a few things about a parabola. Well, this parabola will have any parabola actually, will have a vertex. It's either the lowest point. I'll show you another example where it'll be like a high point, but in this case, it's a low point. That's the vertex. So I do have to show you how to find the vertex without using a graph or Desmos. So we have a formula we're going to usually use to find the vertex other than the Desmos. The first thing I want to do is identify what A, B, and C are. They're coefficients. A is the coefficient of x squared. So that is, in our equation, it's 3. B is the coefficient of your x term. So that's negative 12. And then C is your constant term. That's 5. Okay? That's that. Let's look at this example right here. Here, A is negative 1. B is positive 4, and then C is negative 3. Okay? The important coefficient on here is the A. If A is positive, then we say that the parabola opens up, meaning that it's going to go both ends, they just kind of curve up. They start from the top and they go back, they curve, and then they go back up. If A is negative, though, I'll graph it in a second. If A is negative right here, then the parabola, we say it opens down. Okay? It opens down. So basically, it'll generally have this shape like that. Okay? Let's go ahead and see an example, this example right here. So I'm going to go ahead and plug it in. So y equals negative x squared plus 4x minus 3. See how it goes down. Okay, so let's talk about vertex and axis of symmetry. Vertex is either the high point or the low point right here for I'll just ungraph this. So here's the vertex 2, 7. It's right there. I can just write it out. but I'm not. I need to go ahead and do it algebraically just because you just need to know, but just know that you can always figure it out using Desmos. So to find the x-coordinate of the vertex, we have this formula right here. Okay, so you have this formula, x equals negative b over 2a. So x equals negative b over 2a. So that's negative b, that's negative 12. So I'm going to put another negative over 2 times a, which is negative is positive. So I'll just take the negatives out. 2 times 3 is 6. So 12 divided by 6 is 2. That's where this 2 came from. Okay? Okay, so what I'm going to do here is I will go ahead and use my equation. So I'm going to bring down the 3. And instead of writing x squared, I'm going to plug in the 2 that I found for my x and then plug it in here. So 2 squared minus 12 times 2 plus 5. And then when, of course, I have Desmos right there, I can probably just plug it in. But let's just kind of go through the order of operations here. 2 squared is 4. 4 times 3 is 12. Remember exponents first. Minus 12 times 2 is 24. Bring down the 5. So that's 12 minus 24. That's negative 12 plus 5. And so that equals negative 7. Yeah, well, it's right there, negative 7. There you go. That is my vertex. That's how you find it if you are not using Desmos or any calculator, okay, a graphing calculator. Now, what is this AOS? Well, it stands for axis of symmetry. So any parabola is symmetrical, meaning the left side, if I split it right in the middle, is the same as the right side. So the axis of symmetry will always be a line. So I'm going to say x equals 2. Let me go ahead and graph it here for you. So x equals 2. You see how it's right in the middle right there? So that is called the axis of symmetry. So let's go ahead and do this next one. I'm going to ungraph this, graph this just to have it. So let's find the x-coordinate here. So you're going to say negative b over 2a. So that is negative b is 4 over 2 times negative 1. Okay, what's about? Sorry guys. So this is, negative 4 over 2 times negative 1 is negative 2. Negative is positive. So 4 divided by 2 is positive 2. I think that's what the vertex is. Yep, that's where that 2 came from. All right, let's do the y-coordinate. So again, I'm just going to plug it into my original equation, which is right there. So you're going to do y equals negative x squared. So negative 2 squared. The negative stays on the outside, plus 4 times 2 minus 3. So negative 2 squared, that's positive 4, and this negative comes down. 4 times 2 is 8, and then minus 3. So that will be negative 4 plus 8, that's positive 4 minus 3, which is equal to 1. So that's where that one came from over there. There you go. And then the axis of symmetry is going to be the x-coordinate, the same thing. So x equals 2. Let me go ahead and graph it and show you guys 2. See how it splits it right in half? That's what that is, okay? So I'm going to just quickly draw these on here to graph these on here. 2, negative 7, 1, 2, 3, 4, 5, 6, 7. And then that it was going up. Okay, this little like U shape, try your best. And then for this one, it was at 2, positive 1. And remember the graph is going down because A, my leading coefficient, is going down. And then the last thing I wanted to look at was this word here, maximum and minimum. So the lowest point, we call it a minimum. this happens anytime your A is positive. So every time your A is positive, it's going to go up, right? So you're going to always have a low point when you have, or minimum, when you have A is positive. So this happens when A is positive. Just a little note here for those of you watching. A is positive can be written as A is greater than 0. You'll see this come up later, but that's what that means. It just means positive. So here, we call this the maximum, the highest point, and this happens anytime you have when A is negative. Okay? When A is less than 0. It just means it's negative. Okay? Alright, so that's that. And there's a couple more things I have to show you on the next page, which is just a little review on domain and range of functions. This is something that we talked about before, but it's been a while since we've done it, so I wanted to go over it. Okay? So let's go ahead and find the vertex. The vertex is to find the x-coordinate. You're going to do x equals negative b, which is 8 over 2 times 1. 8 and then 1 is here. So that's negative 8 over 2, which is negative 4. So that's the x-coordinate of the vertex. And then the y-coordinate of the vertex, we're just going to plug in negative 4 here. Now, be careful here. When you're plugging in negative 4, so let me just kind of show you that you need parentheses, especially when you're plugging in negatives, okay? So negative x squared plus 8 times negative 4 plus 15. And that matters because negative 4 times negative 4 is positive 16. The negative goes away. And then plus or minus 8 times negative 4 is negative 32 plus 15. So 16 minus 32, that's negative 16. And then bring over the 15, which is equal to negative 1. So there you go. The y-coordinate is equal to negative 1. And then the axis of symmetry is going to be x equals negative 4. And since A is positive here, which means the parabola is going to go up like that, which means that it's going to have a minimum. Okay? Alright guys, so the last thing I want to talk about is the domain and range. So domain basically is your x-axis. We're trying to look at how much of the x-axis does it fit my graph that I have there. Okay? Well, if I look at the graph, yes, it's going up, but if you notice, it's getting wider, meaning it's going left and right. And since it's going to go off to infinity, it means that it's going to keep going to the infinity on the left and infinity on the right. So negative infinity to positive infinity, it covers all of the x-axis. We say, to say that, we say all real numbers, okay? So the only thing here that's weird is the way we write all real numbers. So we can write it in a set notation. This is like the way I've seen it written before. So we draw a little squiggly bracket, and you're going to say, that's an ugly squiggly bracket. So you're going to draw a curly bracket, and you're going to say x such that x is an element of all real numbers. That R right there represents, it's a symbol. It's not a letter, it's a symbol for real numbers. Now on y, on the range, which is the y-axis, is different. We want to see how much of the graph is in y-axis is on the graph that we have. Well, you notice it's going all the way up, but it doesn't go all the way down. So we're going to have to say y such that y is greater than or equal to my lowest point, which is my minimum, at y equals negative 1, or your negative 1 for your y-coordinate of your vertex. Okay, so anyway, that's domain and range. We'll go over more of it as we go through this packet, but that's what I wanted to show you guys. Okay, thanks guys.